Hi, my name is Helen Byrne. I'm an AI engineer at GraphCore, and this video is explaining training loops and data feeds in TensorFlow 1. So why do we need training loops? The communication between the host and the IPU is slow compared to the execution on device. So we see this overhead if we're calling the hardware for every batch. By placing our training operations inside a loop, we can execute them multiple times without returning control to the host. So why do we need data feeds? Well, when our training operation is placed inside a loop, the inputs to this training operation need to be provided as a stream of values. The standard TensorFlow Python feed dictionaries can't provide data in this form. So when we're training in a loop, we need to feed our data as a TensorFlow dataset. So how do we construct a system that will train in a loop? We just have to follow these simple steps. We need to create a TensorFlow dataset. We need to create an IPU in-feed queue to feed our data to the training loop. We need to create our training loop simply by wrapping our training operation inside the repeat loop function. And lastly, we need to remember to initialize our in-feed within our session scope. So now I'm going to show you what this looks like in the code. So this is my TensorFlow 1 script. I'm generating some random time series data here at the top. Then I'm creating a dataset iterator to feed the graph. Here I've defined my simple RNN model with the loss function and an optimizer and a model update step. Here I'm placing this graph on an IPU device with the inputs from the dataset iterator to feed the graph. This is just utils for variable initialization. Here I'm configuring my IPU system. And I'm selecting a single IPU device. Here I'm choosing to run through my model updates for 1,000 iterations. And I'm going to display a result every 100 of those. And finally, I'm going to run my model. So I initialize my variables, and then I run through 1,000 iterations of my model update. And every 100 of those, I'm going to display a loss. And at the end, I'm going to print out the duration of the 1,000 iterations. Now I'm just going to run through this script. It's a fairly small model, so it doesn't take long to run through, but we can speed up the training of this model by placing our operations inside a training loop and feeding our model with a in-feed dataset, TensorFlow dataset, instead of with the iterator here. So 2.59 seconds was the total duration for this first version. So now we're going to make some changes to our code so that we can run it inside a training loop and run it more efficiently. So first of all, we want to create a TensorFlow dataset. Well, we've already done that in our original code, but we don't need to make it an iterator. So all I'm going to do is comment out these two lines here so that my dataset is as a TF dataset. The second thing that we're going to do is create the IPU in-feed. So here, just below my dataset, I create this host side queue, and it takes my dataset and a name. And next, number 3, I create my training loop by wrapping my operation within a repeat loop. Now, my repeat loop is like a TF while loop. So here, I'm using the IPU loop method, and it takes the kind of the conditional, the number of iterations that I'm going to run on the IPU before returning to the host. Here I've set that to 250. It also takes the function that generates the body of the loop, which is my model function, as before. Then it takes a list of the initial values of the loop carried tensors. So in this case, my loss is going to be returned in my loop. And so I'm just going to set that as a 0 initial value, so a 0 tensor to start with. And then lastly, it takes my infeed, which will feed my data into the loop. So that's part 3. So I guess this is the final bit of part 3, which is in my original code, I had my model here, which was being compiled. Now I've replaced model with training loop, and I no longer need to include the inputs now because my infeed queue has been included within the training loop. And this output here, the compiled output, is an operation that can be called to execute my training loop. So that's part 3, and part 4 is just initializing my infeed. So I'm commenting out here the iterator initializer because I don't have an iterator anymore, and I'm going to instead initialize my infeed. And that's it. So if I run my updated code using the infeeds, I can see that it runs much faster, well, half the time. And you can see now I'm just returning to the host and printing out a loss every 250 iterations. So now we have our model running efficiently with the training loop and our data streaming via our data infeed. And if we're happy to look at the output of our model, our loss in this case, which is returned every 250 iterations, then we don't need to use outfeeds. But if we require a per sample output from our loop, then we can use outfeeds to stream these values back to the host. So let's say we'd like to return the loss from every model update. So first of all, on top of the steps that we've already taken to create the training loop and the infeed, we need to also create the outfeed queue. So again, here I've added the outfeed queue. This generates and adds the outfeed onQ, DQ operations to the graph. It's the counterpart to an infeed. So it manages the transfer of data like tensors or dictionaries of tensors from the IPU graph back to the host. So that's part 3. Part 4 here, we need to onQ the outputs of our model. So here now in my model, I'm onQing the loss and I'm returning it in my model function. So I can onQ here a single tensor or a tuple of tensors or a dictionary of tensors for being outfed from the graph. This operation is placed on the IPU device, and the function returns, this onQ function returns an operation which needs to be executed by returning it in a function or using TF control dependencies. So in this case, I'm returning it in my model function. And next, I need to instantiate my outfeed DQ, which is just this line that I've added here. So this now generates the host side operation to dequeue the outfeed values. And last of all, within my session scope, I now need to dequeue my outfeed. So I do that here. I have to call my dequeue outfeed operation. And now this will return the losses for each of the 250 iterations. So finally, if I run this version of the code that now has the outfeeds included, you can see it takes the same time as the previous version, which just used the infeeds. And it looks pretty much the same. That's because I'm actually just printing the mean of the losses from the 250 steps, 250 iterations here. So I could print out each loss from each iteration, but in this case, I'm just printing out the mean. So if you wanted to avoid creating the loop and the data feeds, then there are methods that do this automatically. So firstly, you could use IPU estimators or IPU pipeline estimators for models that are split over multiple IPUs. And also you could use the IPU Keras model class in TensorFlow 2. And when you call the fit method, this automatically adds the training loop and the feeds for you. Thank you for listening.